dear student, today we have the new chapter, conic section. Conic section. Okay, before talking about this chapter, what is conic section? First of all, let us discuss on this on cone. What is cone? Cone is a three-dimensional geometric shape that traverses from a point to a circular base, and this point is called vertex. This is the circular base, and this is a right circular cone. यो एउटा right circular cone हो जसको यो जुन यो meeting point छ, this point is called vertex, and the line that passes through the center of the circular base and the vertex is called the axis of cone. यो vertex बाट जाने र यता center vertex र center भएर जाने जुन एउटा straight line छ, this straight line is called the axis of cone. यसलाई हामीले axis of cone भनेर भन्छौं र यो सेन्टर सर्कुलर बेसको सेन्टर देखि यता सर्कमफ्रेन्स सम्मको जुन डिस्टेन्स छ, यो डिस्टेन्सलाई हामीले रेडियस अफ द सर्कुलर बेस भनेर भन्छौं, and we denote it by small r or radius of the circular base. Similarly, this straight line, this is called slant, and this is called this is also named as generator of a cone. Generator of a cone. And this angle, the angle formed by the generator with the axis, is called semi-vertical angle. Let us denote it by alpha. This alpha represents the semi-vertical angle. Semi-vertical angle, and radius is perpendicular to the axis. This now this is called a right circular cone. एउटा right circular cone हुनको लागि एउटा vertex छ, एउटा right circular cone यस्तो टाइपको, अनि this is the axis which is the straight line that passes through vertex and center of the circular base. Center of the circular base, and this is the axis, and this is called generator. Suppose यो एउटा कोनको एक्सिस छ मानौ र this is generator. यसरी कोनको यो एक्सिस को वरिपरि यसरी रोटेट गर्दाखेरि हामीले यसरी रोटेट गरेर हेर्यौं भने एउटा फिक्स एंगल, यो एंगल vertical, यो vertical angle सेमी vertical angle constant हुने गरी हामीले यो कोनलाई यसरी यो स्ट्रेट लाइनलाई यसरी यो एक्सिस को वरिपरि रोटेट गर्दाखेरि एउटा जुन थ्री डाइमेन्सनल जियोमेट्रिक शेप बन्छ, यसलाई हामीले राइट सर्कुलर कोन भनेर भन्छौं र यो रोटेट गर्दाखेरि यो सेमी vertical angle थ्रू आउट अफ द रोटेसन मस्ट बी इन कांस्टेंट. यो कांस्टेंट हुनै पर्छ. यो कांस्टेंट भएन भनेपछि त्यो हाम्रो राइट सर्कुलर कोन बन्दैन. Okay, now the sections of these right circular cones are generally called right circular conic section. The sections of these cone, यो यसरी अब एउटा कोनलाई हामीले कुनै प्लेनले इन्टरसेक्ट गर्दाखेरि बन्ने जुन डिफरेन्ट टाइपका जियोमेट्रिकल शेप्सहरु छन्, यी जियोमेट्रिकल शेप्सहरुलाई conic section भनेर भन्छौं. First of all, let us define what is conic section. A conic section is a curve open or closed. A conic section is a curve open or closed which is obtained by the intersection of a cone and the plane. A conic section is a curve open or closed. त्यो curve open पनि हुन सक्छ, closed पनि हुन सक्छ, and which is obtained by the intersection of the cone एन्ड द प्लेन। त्यो प्लेनलाई कट गर्ने जुन त्यो कोनलाई कट गर्ने प्लेन छ त्यसको कट गर्दाखेरि आउने डिफ्रेन्ट जोमेट्रिकल शेप्सहरूलाई हामीले कोनिक सेक्सन भनेर भन्छौँ। अब नाउ लेट अस डिस्कस about these conic sections. The conic section, if we intersect a right circular cone by a plane, if a plane intersects a right circular cone perpendicularly with the axis of a cone, right circular cone, यदि एउटा प्लेनले, this is intersecting plane, एउटा इन्टरसेक्टिङ प्लेनले त्यो कोनको एक्सिससँग 90 डिग्री परपेन्डिकुलरली हुने गरी इन्टरसेक्ट गर्दाखेरि वी अब्टेन अ कोनिक सेक्सन नेम्ड एज सर्कल। एउटा कोन, राइट सर्कुलर कोनलाई एउटा प्लेनले त्यसको कोनको एक्सिससँग परपेन्डिकुलर हुने गरी काट्यो भने वी गेट अ क्लोज्ड कर्व नेम्ड एज सर्कल। Now the second one, when a plane intersects a right circular cone, not perpendicularly, so that suppose alpha is the semi-vertical angle and beta is the angle between the axis and plane, then if beta is greater than alpha, the angle between the axis of cone and the plane, intersecting plane, is greater than semi-vertical angle, then a closed curve, oval shaped curve we obtain. This is called ellipse. एउटा प्लेनलाई, कुनै एउटा राइट सर्कुलर कोनलाई एउटा प्लेनले इन्टरसेक्ट गर्दाखेरि जुन यो एंगल बिट्विन एक्सिस एन्ड प्लेन छ त्यो एंगल बिट्विन एक्सिस एन्ड प्लेन इज ग्रेटर देन द सेमी भर्टिकल एंगल हुने गरी यसरी इन्टरसेक्ट गर्दाखेरि वी गेट अ क्लोज्ड कर्व व्हिच इज कॉल्ड इलिप्स। नाउ वी हैव अ थर्ड टाइप अफ कर्व obtained by the intersection of right circular cone and the plane. When a plane intersects a right circular cone parallel to its generator, if a plane intersects a right circular cone parallel to its generator, if a plane intersects a right circular cone parallel to its generator, then the section of a cone so obtained is called parabola. Okay, sorry, हामीले intersect गर्यो भने if a plane intersect a right circular cone parallel to its generator, then the section of a cone so obtained is called parabola. यदि हामीले कुनै एउटा प्लेनले एउटा मानौ कटिङ प्लेन छ, सपोज नाइफ, यसले यसरी प्लेनलाई कट, एउटा कोनलाई कट गर्यो भने यो जेनरेटर, दिस इज द जेनरेटर अफ अ कोन, जेनरेटरसँग प्यारलल हुने गरी इन्टरसेक्ट गर्यो भने यहाँनिर इन्टरसेक्ट भएको साइड हाम्रो यो सी शेप बन्छ, यस्तो सी शेप्ड कर्व बन्छ भने यसलाई हामीले प्याराबोला भन्छौँ। सी शेप्ड यस्तो पनि हुन सक्छ, जस्तो पनि हुन सक्छ, यस्तो टाइपको सी शेप्ड कर्व होइन। plane intersects a right circular cone parallel to its generator, then the curve so obtained is called parabola. The shape of this parabola is like this or any other, and this is an open curve. Another type of curve, when two right circular cones are intersected by this. When two right circular cones are intersected by a plane like this is the axis of cone, almost parallel. Sometimes you, this is semi vertical angle, almost parallel हुने गरी हामीले intersect गर्यौं भने this type of curves we obtain a pair of two open curves, a pair of two opposite directions, like two opposite parabolas or two open curves, we can see in this type. Or sometimes if the cone are in this form, if the cone are in this form, when two right circular cones are intersected by a plane, this is a plane and this is the axis of two right circular cone. When two right circular cones are intersected by a plane, then a pair of this type of curves are called hyperbola. If the right circular cone are in the form of particular, uh, kept in particular form, then we obtain this type of curve. And if the right circular cone are in this form, then we get another set of open curve. And suppose this is the axis of both cones, and if we cut these right circular cone by a plane, this is plane, cutting plane, and we get this type of open curve, and these are called these geometric shapes are known as hyperbola. Let us define conic section. Let us define conic section. Conic section is the locus of a point. A conic section is the locus of a point which moves in a plane, which moves in a plane in such a way that the ratio of its distance in such a way that the ratio of its distance from fixed point to fixed straight line is always constant. Is always constant. The fixed point is called focus, comma, the fixed straight line is called directrix, and the constant ratio is called eccentricity. The constant ratio is called eccentricity, and we denote it by the small letter e. Now let us define what is parabola, what is ellipse, and what is hyperbola in terms of eccentricity. Thus, now define parabola. Define parabola. Parabola, a parabola is the locus of a point which moves in a plane in such a way that it is equidistant. It is always equidistant from fixed point called focus and fixed straight line called directrix. Thus, a parabola is the locus of a point which moves in a plane in such a way that it is always equidistant from fixed point called focus and fixed straight line called directrix. Alternatively, parabola is a conic section having eccentricity having eccentricity 1. A parabola is a conic section having eccentricity 1. In this way, we can alternatively define parabola as a conic section having eccentricity 1. Thank you. As a remark, note ellipse is a conic section. Ellipse is a conic section having eccentricity greater than 1. Note, ellipse is a conic section having eccentricity greater than 1, and hyperbola is a conic section, is a conic having eccentricity greater than 1. Okay. Note, ellipse is a conic section having eccentricity less than 1, and hyperbola is a conic section having eccentricity greater than 1. And these are the three types of conic sections. Conic sections are in short named as conic only. So conic sections in short we can write conic also, and these are the three special type of conic sections. And there is another type of conic section which is a circle, and the eccentricity of the circle is 0. Suppose if we found a open curve, this type of open curve which is obtained by the intersection of a plane and the right circular cone, this is a parabola. Suppose this is a fixed point and this is fixed straight line. The fixed straight line is called directrix, fixed straight line, This is called directrix, and this is a fixed point. Let us denote here. This is fixed point. Let us say F fixed point. We fix here, and this is called focus. Fixed point लाई focus भन्छ. A line that passes through fixed point and perpendicular to the directrix is called the axis of a conic section. A line that passes through focus. Focus बाट पास हुने र डाइरेक्ट्रिक्स सँग परपेंडिकुलर हुने जुन यो लाइन छ, दिस इज कल्ड एक्सिस अफ कोनिक. एउटा स्ट्रेट लाइन जुन फोकसबाट पास हुन्छ र फिक्स्ड स्ट्रेट लाइन दैट इज डाइरेक्ट्रिक्स सँग परपेंडिकुलर हुन्छ भने त्यो लाइनलाई, त्यो स्ट्रेट लाइनलाई हामीले एक्सिस अफ अ कोनिक भनेर भन्छौं. कोनिक भनेको कोनिक सेक्सन, यो सबैमा हुन्छ. इलिप्समा, हाइपरबोला र प्याराबोला तीनटैमा हुने हुनाले हामीले यहाँनिर कोनिक मात्रै लेख्यौं. And here is another point. Let us say, suppose this point of intersection of the directrix and axis is Z, and this is the point A. A is the point of intersection of the curve and axis, and this point A is called vertex. Vertex is the point. In this way, vertex is the point of intersection of the curve and axis. Now there are another type of definitions, like there is a one chord which passes through focus and perpendicular to the axis of parabola or ellipse or hyperbola. Suppose PQ, this chord PQ is called the latus rectum. This is a special type of focal chord. A chord that passes through focus is called focal chord. For example, suppose this dash type of chord is a suppose this LM is a focal chord. A chord that passes through focus is called focal chord, and PQ is a special type of chord, focal chord, which is perpendicular to the axis and passes through the focus. So PQ is called latus rectum. Sometimes it is also known as double ordinate or focal width and etc. Especially this chord PQ is called latus rectum or focal width, and LM is the focal chord. A chord that passes through focus is called focal chord. फोकसबाट पास हुने कर्डलाई हामीले फोकल कर्ड भनेर भन्छौं. PQ एउटा स्पेशल टाइपको फोकल कर्ड हो, किनकि यो फोकसबाटै पास हुन्छ र सँगसँगै एक्सिसमा परपेंडिकुलर पनि हुन्छ. अरु कर्डहरु एक्सिससँग परपेंडिकुलर हुन सक्दैनन्. त्यसैले ल्याटस रेक्टम भनेको हाम्रो के हुन्छ, एउटा स्पेशल टाइपको फोकल कर्ड मानिन्छ. अनि A is the point of intersection of the curve and axis. त्यसैले यो कर्व र एक्सिसको point of intersection लाई हामीले vertex भनेर भन्छौं. Okay, now we have the question. Find the equation of the parabola with vertex at 2,3 and the focus at 5,3. Solution. Here, vertex h, k equals 2,3 and focus equals to 5,3. The y coordinate, यहाँ vertex र focus को y coordinate same भएकोले y equals to something, y equals to 3 जुन हुन आयो. Y equals to 3 is the line parallel to x-axis. So y equals to 3 भन्ने line parallel to x-axis भएको हुनाले यसको axis of the parabola is parallel to x-axis. In this case, the equation of parabola is y minus k को whole square equals to 4a into x minus h हुन्छ, where h, k भनेको हाम्रो vertex छँदैछ. अब a को भ्यालु निकाल्न सक्यौं भने we will find the required equation of the parabola. Also, we know that if the vertex and focus are given, then at that time a equals to the distance between vertex and focus. हैन, vertex र focus दिएको केसमा a भनेको distance between them हुन्छ. हैन, vertex र focus को बीचको distance भनेको a हुन्छ. a को भ्यालु निकाल्न सक्यौं भने we get the required equation of parabola. Let us find the equation. Here vertex equals to 2 comma 3 and focus 5 comma 3. The y coordinate of the vertex and focus are same, so the axis of required parabola is parallel to x-axis. So the axis of required parabola is parallel to x-axis. Then its equation will be of the form y minus k whole square equals to 4a into x minus h हुन्छ. That is y minus 3 whole square equals to 4a into x minus 2 h equals to 2 छ. अब a को भ्यालु निकाल्नु पर्यो. Let it be equation 1. We know that a equals to distance between vertex and focus. We know that a equals to distance between vertex and focus. Therefore, a equals to root over distance निकाल दिउँ x2 minus x1 5 minus 2 को whole square plus y2 minus y1 3 minus 3 को whole square equals to 3. That is a equals to 3. So from 1 y minus 3 को whole square equals to 4 into 3 into x minus 2. Therefore y minus 3 को whole square equals to 12 into x minus 2, which is the required equation of parabola. In this way, we can find the equation of parabola by using all these methods in this way also. We have the another question. Find the equation of parabola whose vertex at minus 1 comma 1 and directrix is y equals to 3. अब यो क्वेशन कसरी गर्ने त हामीले भन्दाखेरि प्याराबोलाको भर्टेक्स दिएको छ र डाइरेक्ट्रिक्स दिएको छ. डाइरेक्ट्रिक्स एन्ड एक्सिस आर अलवेज परपेन्डिकुलर टु इच अदर. सो गिवन पहिला गिवन कुरो लेखौँ. भर्टेक्स एच कमा के ले रिप्रेजेन्ट गर्छौँ हामी. भर्टेक्स एच कमा के इक्वल्स टु माइनस 1 कमा 1 छ एन्ड डाइरेक्ट्रिक्स y equals to 3. Y equals to something is the line parallel to x-axis. Here directrix y equals to 3 is directrix y equals to 3 is parallel to x-axis. So the axis of required parabola. So the axis of required parabola will be parallel to y-axis and its equation will be of the form x minus h को whole square equals to 4a into y minus k. That is x minus plus 1 whole square equals to 4a into y minus 1. Let it be 1. Just to y equals to 3. In parabola 1, now in parabola 1, Equation of directrix. Equation of directrix 1, parabola 1. In equation of directrix is y equals to k minus a. In parabola 1, equation of directrix is y equals to k minus a. That is y को भ्यालु 3 छ equals to k को भ्यालु 1 छ minus a. Therefore a equals to minus 2. Hence from 1 x plus 1 को whole square equals to 4 into minus 2 into y minus 1, or x square plus 2x plus 1 equals to minus 8y plus 8. Therefore x square plus 2x plus 8y minus 7 equals to 0, which is the required equation of parabola. Which is the required equation of parabola. In this way, we can find the equation of parabola when the vertex and directrix is given. We have the another most important question. Find the coordinates of vertex, focus, equation of vertex, focus, equation of directrix and length of lattice rectum. Here we have two questions. One is y square equals to 16x and the another one is y square plus 4x plus 2y minus 15 equals to 0. Solution first. पहिलो को सल्युसन गरौँ. Here y square equals to 16x छ. अब यसमा कम्पेयर गरौँ. पहिला यसलाई स्ट्यान्डर्ड फर्ममा लैजाउँ. स्ट्यान्डर्ड फर्ममा लैजाँदाखेरि therefore y square equals to 4 into 4 into x भयो. Comparing this equation with y square equals to 4ax and we get हामीले के पायौं a equals to 4. Then according to question, find the coordinate of vertex. In this case, this is the standard equation of the parabola. Standard equation को फर्ममा भएकोले यो केसमा coordinate of vertex equals to then coordinate of vertex equals to a, 0 हुन्छ. स्ट्यान्डर्ड केस भएकोले equals to 4, 0 coordinate of vertex भयो. अनि coordinate of focus equals to a, 0 हुन्छ. Comparing this equation with y square equals to 4ax, we get a equals to 4. Then this is the standard type of parabola. So its coordinate of vertex equals to 0, 0, and coordinate of focus equals to a, 0 equals to 4, 0. And equation of directrix is x equals to minus a हुन्छ. That is x equals to minus 4. Therefore x plus 4 equals to 0. Length of lattice rectum equals to 4a equals to 4 into 4 equals to 16. This completes your solution. And length of lattice rectum equals to 4a equals to 4 into 4 equals to 16 units. This completes your solution. Solution of other question is, first of all, we have to convert or reduce this equation into standard form. अब स्ट्यान्डर्ड फर्ममा यसलाई रिड्युस गर्दाखेरि y भएकाहरू एक ठाउँमा राखौँ, x भएकाहरू कन्स्टेन्टलाई राइट साइडमा लैजाउँ, किनकि यहाँ y स्क्वायर छ। y स्क्वायर भनेको हाम्रो y माइनस k को होल स्क्वायर इक्वल्स टु 4a इन्टु x माइनस s टाइपमा रिड्युस गर्नु मिल्छ यसलाई। त्यही भएर लेफ्ट साइडमा स्क्वायर भएका टर्म राखौँ। y स्क्वायर प्लस 2y इक्वल्स टु राइट साइडमा माइनस 4x प्लस 15 भयो। यसलाई पर्फेक्ट स्क्वायर बनाऊ, और y स्क्वायर प्लस 2 इन्टु y into 1 plus 1 square minus 1 square equals to minus 4x plus 15, or y square plus यसलाई हामीले होल स्क्वायरमा लेख्दियौँ। यो भनेको यहाँदेखि यहाँसम्म हाम्रो y plus 1 को होल स्क्वायर छ इक्वल्स टु माइनस 4x, यो उता गएपछि प्लस 16 भयो, और y plus 1 को होल स्क्वायर इक्वल्स टु माइनस 4 कमन आएपछि x माइनस 4 बाँकी रह्यो। देयरफोर y माइनस माइनस 1 होल स्क्वायर इक्वल्स टु 4 into minus 1 into x minus 4. Now comparing this equation, with y minus k को होल स्क्वायर equals to 4a into x minus h, we get k equals to minus 1, a equals to minus 1, and h equals to 4. Coordinate of vertex. H comma k equals to 4 comma minus 1, coordinate of focus equals to h plus a comma k equals to 4 minus 1 comma minus 1 equals to 3 comma minus 1. Equation of directrix is x equals to h minus a, that is x equals to 4 minus minus 1, therefore x minus 5 equals to 0. And the length of latus rectum equals to 4a equals to 4 into minus 1 equals to minus 4 equals to 4, because length cannot be negative. This completes your answer. We have remarked the equation of tangent to the parabola x square equals to 4ay at x1 y1 is x1 equals to 2a into y plus y1. Remark say 1. Remark 2. The point of contact for the parabola y square equals to 4ax and tangent y1 equals to 2a into x plus x1, or y equals to mx plus a by m is a by m square comma 2a by m. Okay, now we have the question. Find the equation of tangent and normal to the parabola y square equals to 8x at 2 comma minus 4. अब यो प्याराबोला y square equals to 8x भन्ने प्याराबोलामा 2 comma 4 minus 4 भन्ने पोइन्टमा इक्वेसन अफ टेन्जेन्ट एन्ड नर्मल निकाल्नु. यसका लागि फर्स्ट अफ अल हियर we have y square equals to 8x, therefore y square equals to 4 into 2 into x. Comparing this equation with y square equals to 4ax, we get a equals to 2. Also given point is equals to 2 comma minus 4. Now equation of tangent to the given parabola at given parabola y square equals to 8x at 2 comma minus 4 is y1 equals to 2a into x plus x1. The equation of parabola y square equals to 4ax at x1 y1 is y1 equals to 2 into a भनेको 2 छ, x plus x1 x1 y1 हाम्रो यो पोइन्ट छ, x1 y1 यो भयो अनि a को भ्यालु 2 छ, त्यसैले y into y1 equals to 2a into x plus x1 इक्वेसन भयो. अब यसलाई अन सिम्प्लिफिकेसन यो 4 ले यो 4 क्यान्सल गरेपछि minus y equals to x plus 2 भयो. Therefore x plus y plus 2 equals to 0. Therefore x plus y plus 2 equals to 0, which is the required equation of tangent. Here again here slope of tangent, say m1 equals to minus 1. Therefore slope of normal, say m2 equals to minus 1 upon m1 equals to 1. m1 को भ्यालु minus 1 छ, minus ले यसलाई मल्टिप्लाई गरेपछि minus हुन्छ, because tangent and normal are perpendicular to each other. So slope of normal equals to 1. Now equation of tangent. Now equation of normal to the given parabola y square equals to 8x at 2 comma minus 4 is y minus y1 equals to m into x minus x1, or y plus 4 equals to x minus 2. Therefore x minus y minus 6 equals to 0, which is the required equation of normal. Which is the required equation of normal to the given parabola y square equals to 8x at 2 comma minus 4. We have another question. Find the equation of tangent to the parabola y square equals to 3x parallel to the line y equals to 2x plus 1. यो y equals to 2x plus 1 सँग parallel हुने हामीले tangent को equation निकाल्नु छ to the parabola this. Suppose this is the parabola y square equals to 3x and there is a line. Now we have to find the equation of tangent. Any line which touches the curve is called tangent. यो tangent के छ, एउटा कुनै given line छ, यो सपोज यो लाइन छ y equals to 2x plus 1 सँग parallel छ. यो टेन्जेन्ट योसँग प्यारलल छ हामीले फाइन्ड गर्नुपर्ने इक्वेसन अफ दिस टेन्जेन्ट यसको इक्वेसन वाट दिस इज द क्वेसन एन्ड दिस इज टेन्जेन्ट एन्ड दिस टेन्जेन्ट इज प्यारलल टु दिस लाइन so if this tangent is parallel to this line so slope of this line is equal to slope of this tangent so we have to find the equation we have to write the equation of tangent in slope form that is y equals to mx plus a by form मा हामीले इक्वेसन अफ टेन्जेन्ट निकाल्नु पर्ने हुन्छ यहाँनिर अब यसका लागि a र m को भ्यालु चाहियो m को भ्यालु लाइनबाट लिन्छौं a को भ्यालु प्याराबोलाबाट निकाल्छौं then we get the required equation of tangent so here y square equals to 3x therefore y square equals to 4 into 3 by 4 into x यसलाई हामीले स्ट्यान्डर्ड फर्म बनाउनको लागि तल र माथि यो 4 ले 4 by 4 गर्यौं 4 ले 4 क्यान्सल गर्दा माथिकै भ्यालु आइहाल्छ त्यसैले comparing this equation with y square equals to 4ax we get a equals to 3 by 4 let the required equation of parabola be let the required equation of tangent be y equals to mx plus a by m that is y equals to mx plus 3 by 4m let it be 1 given line is y equals to 2x plus 1 since given line is parallel to the required tangent so slope of tangent equals to slope of line equals to 2 so slope of tangent say m equals to slope of line हाम्रो y equals to mx plus c सँग कम्पेयर गर्दा m को भ्यालु 2 छ त्यसैले slope of tangent m equals to 2 भयो therefore so from 1 y equals to 2x plus 3 by 4 into 2 LCM लिँदाखेरि therefore 8y equals to 16x plus 3 which is the required equation of tangent which is the required equation of tangent अब कहिलेकाहीँ यही क्वेशनमा find the equation of the normal पनि भन्न सक्छ हैन द normal is also parallel to the same line suppose line को इक्वेसन यही छ अब यो लाइन सँग normal parallel हुने normal को इक्वेसन निकाल भन्यो भने in this case we have to find the slope of normal equals to slope of line हुन जान्छ अनि slope of normal equals to slope of line say suppose the slope of line equals to m equals to 2 छ अब कहिलेकाहीँ यही क्वेशनमा अहिले त हामीले भर्खर टेन्जेन्ट को इक्वेसन निकाल्यौ फाइन्ड द इक्वेसन अफ टेन्जेन्ट parallel to the line y equals to 2x plus 1 भन्यो कहिलेकाहीँ के सोधिन्छ भने find the equation of normal which is also equation of tangent and normal both are parallel to the same line in practice this is impossible but in calculation we can find the equation of normal here the given line is y equals to 2x plus 1 a line is parallel to the normal in this case the slope of line equals to slope of normal and if the slope of normal equals to 2 then the equation of normal in m form is y equals to mx minus 2am minus am cube using this formula we can find the equation of normal